Okay, I'm on page 138 in the packet, and we're going to go over linear regression, just some of the basic concepts of what that means, and we're going to have the calculator actually find the best fit line, because the mathematics, there's some advanced linear algebra behind the mathematics, and we won't do that in this class, but the calculator can actually very quickly, once you get the data in, help you do that. So first of all, the whole point here is that we have some sort of data, which typically could be some real world data, but I just have this made up example of numbers here to get us started, where you have two different variables that you think relate to each other. So you have an x variable and a y variable, or an input and an output. They call them independent and dependent in statistics, but we have the input x values and the output y values. And the first thing we can do with those is just make what's called a scatter plot, and they call it that because, as you can see in the picture here, when you plot it, typically it just looks like the scatter. Sometimes they say the scatter from a shotgun, from the buckshot. The points are just scattered around. So all of that I've done to make this picture, of course I used a computer to do it, but so you take the point 2, 12, so I go to 2 in the x direction, 12 in the y direction, and there's a point. And then I plot 3, 9, 3 1/2, 8, and so forth, and I get these. You can actually do this on the calculator as well, so let me pause and fire up the calculator and do that. Okay, so I have here a virtual excuse me, TI-83, so any TI-83 plus or TI-84 is going to work in the same way. And so the first thing we have to do is actually enter the data in, which will be in the list, which is above the stat button. So you hit second and stat to get into this menu. Now you should have L1 through L6. If you don't, it's possible to bring those back. Actually, to work with them, you go into the list. If you just stat and edit is how we're going to edit one. But so to see the list, you hit second stat, and there are the lists. But to edit one, I need to hit just the stat button, and then to start one, I need to edit. So I just hit enter. And here, again, you should now be able to enter the entries into L1 through L6. And it's possible to rename these or even accidentally delete one. So let me show you what to do if that's the case on your calculator, because it's a lot easier if we use L1 and L2. So let's suppose, though, that someone has deleted. I can actually do that and delete L1. You don't want to do that, but let's say you go in, you hit stat, edit, and you find that L1 is not actually there. Well, that's really easy to set back to the default mode here. Just hit stat and go down and run number 5, setup editor. So I'm just going to hit the number 5 and then hit enter, and it'll say done, and you can't see that it actually did anything, but if you hit stat and edit, you go back and L1 through L6 are restored if they were renamed or deleted. And so you may have data in here. Let's say someone had already entered some things and you have something in list 1. You could just type over that, or the quickest way, you go up to the name and don't hit delete like I did earlier. That'll delete the entire list, but hit clear and enter, and that'll clear a list. So you go up to the name with the arrows, hit clear and enter, and that'll clear the list, which is probably the easiest way to start when you enter. That way you don't have to worry about having any extra numbers in there. Okay, so let's see, I need to bring up the data. Okay, so I think you can see the numbers and the screen now. And so we're going to put the x's excuse me, into L1, and I'm just going, you can use the, let's see, just the number pad. I'm going to have to cover part of this. So 2 and enter, 3 and enter, 3.5 and enter. And so just keep entering the x values and hit enter. Let's see, I need 2 4s and 5, 7, 9. Okay, and then right beside each of those, we're going to enter the y value. And the order is important because we're entering the points. I need 2, and right beside that I need the 12. So the order is very important. You need to make sure they're lined up right. So we have 2, 12, 3, 9, 3.5. Let's see, we got 8, 7, 5, 3, 1. And 0.5. Again, excuse me, I'm getting over a case of strep throat here, so apologize if I cough. At least I'm virtual and not contagious. So you have to enter in the x's and the y's in L1 and L2. One good quick check is to look at the end and just make sure that you have the same number in each list, that I don't have extra entries in one list versus the other. So the calculator is going to do all the computation. It's very important that you have the data entered correctly, so you might want to double check that. Let's go ahead and make the scatter plot while we have this in here. So let's hit y equals real quick and clear out. If you have anything entered, like say you'd plotted x squared plus 2 or something, clear that out. Hit the clear button and clear that out. And then you hit second and y equals to work with the stat plots. And then we can do up to 4 of these. I only need 1, so I'm going to hit enter and go into plot 1's options. So you can turn it off and on just by moving on top of the word and hitting enter. To turn it on, I move to on and hit enter. And then there are different types of graphs we can do in statistics, and we're going to do the scatter plot here in our algebra class, so make sure that that's selected. If it's not, let's say this thing that's called a histogram was selected. You just go on top of the one that looks like a scatter plot and hit enter. And then the calculator knows you need 2 lists. The default values are to put the x's in L1 and the y's are in L2. If your calculator doesn't say that, so let me clear and say, you could put them in any list as long as you put the name in here, but it's a lot easier just to use L1 and L2. So to get L1, you hit second and the 1 button has L1 above it. The lists are above 1 through 6. You hit second and then the number. So to get L2, if it wasn't already in there, you hit second and 2 to get L2. And then the mark, doesn't really matter which of these you pick, that's the symbol it's going to plot. I think it's best to use the little squares because they're easiest to see. And then I could just hit graph, and my window is going to depend on how I have it set there. If I want it to look like what's on the screen, I can hit the window button, and I did an x-min of -1 to an x-max of 10 with a scale of 1. If you look back at my original picture, I went from -1 to 10 by 1s, and then from 0 to 14 in the y direction. There's a quicker way to pick a scale that I'll show you in a minute, but 0 to 14. So one way is just to look at the data and pick values that are big enough to make sure you see all of the numbers. My x's run from 2 to 9, so I did -1 to 10 to go a little more in each direction. And the y values run as high as 12. I went up to 14 and did a scale of 2. And then when I graph, it's going to look very, very similar to what I have here with the computer. A quick way, if you hit zoom and number 9, I'll scroll down so you can see it. You can just hit zoom and then hit the button 9 without scrolling down, but that's zoom stat. It basically looks at the data and makes sure that it picks values above and below the max and mins, and you can see all of the points on the screen. Okay. So that's how to enter the data and make a scatter plot with the calculator. Okay, so let's go back to a little bit of the theory here. Now what we would like to do is come up with a function. Y is a function of x, or we could plug in x and figure out exactly what y would be. Well, unfortunately in the real world, there is no nice function that's going to fit most of your data, especially a line is not going to fit through all of the points. So if we pick a particular line and we take an x value such as 5 here, and we go up and we find the y value on the line, which would be about 6 or so, there's going to be some error because the actual y value that goes with that is down here. So there's an error. This vertical distance is showing me the error. So any point that I pick, I go up and I look at the distance from the line, the vertical distance from the line to the point, I get an error. Our goal is to try to minimize those errors. And what they actually do mathematically is minimize the sums of the squares of those errors. You square it so that positives and negatives don't cancel each other out, and it's a lot easier mathematically than using absolute value, which has that sharp point on the function. X squared is a much nicer function to work with mathematically. So the goal, which the calculator is going to do this for us, but the goal is to find the line that is the best fit. So sometimes they call this the best fit line, or just the regression line, or the least square regression line, LSR, the least square regression line, because what it's doing is minimizing the sum of the squares of the errors. So the calculator can give us a line that will do that. It'll basically minimize the errors and give us the best fit line. So that's what I'm going to show you next. And it's really easy to do that if you've already entered the data in. That's the hard part's entering the data in, or the time-consuming part. So let me bring back up the calculator. So now, if you hit the stat button again, we've already entered the data, and you go over 1 with the arrows to the calculation menu. Number 4 will give you a linear regression. Let me point out, so will number 8. If you look at 4 and 8, they're very similar. They both say LINREG, linear regression. Number 4 says AX plus B. That's set up to match the algebra books. They don't use an M, but A is going to be your slope and B is your y-intercept, AX plus B. Number 8 is set up more like your modeling books, where you start with a value and then you add copies of the slope. So if you look on 4, A is the slope and B is the y-intercept. On 8, A is the y-intercept and B is the slope. So it doesn't matter, you just have to be careful and look at the model you're using. So we've entered the data. I can just hit number 4, and as long as you put the x's into L1 and the y's into L2, that's the default. The calculator assumes that. You just hit enter and it'll run this linear regression for us. Some of you may be seeing R values, which are correlations right now, but those are turned off by default on your calculator and they're turned off here. So what I see is that y equals ax plus b, and it tells me the a value, the slope, is negative 1.6 something here. So if we were just going to round, we could say that y equals negative 1.6x plus 13.4. Okay? So it gives me the model as ax plus b, and it tells me the a and the b value. So if I was wanting the least square regression line, I would write down y equals negative 1.6x plus 13.4. We usually round to 1 or 2 decimal places. So that's it. The correlation, you might want to turn that on just to see. It tells you how strong the fit is. These are scattered out a little bit. They're not a perfect line. You only have to do this once, but we have to go into the catalog is the only place I know to find it. You hit second and 0. That will put you into the catalog, and we need to find something called diagnostic on. We could just keep scrolling, but one partial shortcut is to hit the button that has D above it, and it'll jump down to the D's. And there's diagnostic off and diagnostic on. So I choose diagnostic on, just hit enter, and again it just says done, kind of like when we did the setup editor. But if I go back now and I do stat, calc, and run number 4 again, still gives me the model, which for this class is really all I need, but it also gives me r squared and r. Now r is called the correlation. I'll just tell you a little bit about it. It's between negative 1 and 1, always, the way it's calculated. The closer it is to negative 1 or 1, the better the line is. The data is more linear. So this data, even though it's scattered out a little bit and doesn't perfectly follow a line, it's fairly linear. Our model is a negative 0.92, so pretty strong. The negative tells me that it's also in the negative direction. The line has negative slope. As x increases, y decreases. So that's it. That's how you use the calculator to find the line of best fit. Okay, and I would just like to finish the video with a couple of examples of types of questions you can answer once you have the model. Okay? So remember, we had a set of particular x values and y values that we knew the exact x's and y's, but we can also use these to make predictions and find information about other x's and y's that aren't in our data. This is what statisticians would do. Okay? Or this is an overlap of statistics and algebra. We use these techniques in both types of classes. So we have our equation that we found, y equals negative 1.6x plus 13.4. So one type of question is just the evaluation question, or the prediction question. Sorry. So if you know an x value, you can predict with the model of the y value. You plug in the x and find the y, which is very straightforward. Okay. So predict y if x is 4.5, for example. Well, I just plug in the 4.5 into the equation and compute it. So negative 1.6 times 4.5 plus 13.4. Punch that in my calculator real quick. I got 6.2. So according to the model, if x is 4.5, we would predict the y to be 6.2. Now remember, we're modeling from the real world, so depending on what this is modeling, that may never exactly occur in the real world, but this is our best prediction based on the model of approximately what we would expect the value to be. You can do the opposite, where you know the y and you find the x, so finding the input when you know the output. So my question here, just as an example, according to the model, what x value would result in y equals 10? So there you know that y equals 10, you plug that into the model, but you don't know x, and then you just solve the equation. So I subtracted the 13.4 from both sides and got negative 3.4, and then divided both sides by negative 1.6. I went ahead and canceled the two negatives, but you wind up with positive 2.125. Okay? So I mean, that's basically it. I guess one last thing I'll show you. Usually I ask you to graph the equation as well. So we have our graph, our scatter plot there, which you just plot the points. And we can add our line. We're just graphing a straight line, which isn't too hard to do by hand, but on the calculator I can hit y equals and put in negative 1.6x plus 13.4, and I can see my line and my data together. Alright, so that's my introduction, quick introduction to linear regression video.